Hey everyone, I'm James Char-Early, Senior Developer Advocate at Snowflake. Today, I'm joined by Abhinav Vadrevu, a product manager working on AI products here at Snowflake. What we want to talk about is building trusted agents with Cortex Code. So here's the reality. Agents are only good as the semantic context you give them. Without a strong foundation, even the best LLMs will misinterpret your metrics, give inconsistent answers, and lose user trust fast. That's where semantic views come in, and that's where Cortex Code changes the game. And it's worth noting, semantic views aren't just for AI. They bridge the gap between business intelligence as well as AI, so your agents and your business intelligence platforms all speak the same language. But today, we're going to go deep on the agent side. How to go from a promising POC to a production system people actually rely on. Abhinav has been in the trenches on this, so we're going to get a lot of great insights. So we're going to pick his brain, and he'll show us a live demo with Cortex Code, and we'll wrap up with your questions. So drop them in the chat as we go. Actually, as we go through, we may answer those questions as well. So from the get-go, please ask your questions. So I want to welcome Abhinav, and let's get into it.
Hey, James, great to see you. And hey, everyone, thanks for joining. I'm Abhinav, product manager here at Snowflake, working on various things relating to agents, semantic views, and some of our Cortex Code skills to create and edit those agents and semantic views. Maybe to get started, let me just share my screen and show you a little bit about what it takes to get started with creating an agent and semantic view. Give me a minute here while I get my screen on. One sec. And in the meantime, as James said, feel free to sort of start submitting any questions or thoughts, and I'm happy to start answering them. So this is Cortex Code, and what I wanted to show you is something that I just started running before this session, which is how to create a semantic view. And all I said was, hey, help me create a semantic view. Many of you have actually tried this already. I gave it a demo schema and name for the semantic view, and I told it what actual tables to run it on. And so what it actually does under the hood is it takes a look at those tables, reads through them, figures out all the context it needs, and then it goes and runs essentially what actually runs in our UI today, which is a bunch of deterministic processes that look at query history and a bunch of other sources to try and create the best possible initial semantic view. So it does a bunch of things. It executes SQL, checks the tables and so on, understands the descriptions that it might want to put in and so on. And then it even, I didn't have a warehouse configured originally, and so it actually found the default warehouse and everything for me. And then it went ahead and created a YAML for the semantic view. It took a look at the YAML, actually validated the YAML, and then created it with, I'd asked for 6 tables. I guess there's 33 columns in there, and initially no relationships. And so it went ahead and created all of that. And so let's see what it actually produced. So it actually produced a semantic view, and it actually asks me, do you want to enhance relationships, primary keys, deploy to Snowflake? What do you actually want to do? And I am going to say, well, firstly, yes, let's deploy to Snowflake to begin with. And this is actually going to create a semantic view object. So far, we've only created a semantic view YAML file on my laptop. And then after creating the semantic view, I think the next big thing that we're going to want to do is create an agent so that you can actually talk to the semantic view. And so I might say something like, help me create an agent in this schema using this semantic view. Just want to call out a couple of things. One of the things I did earlier for the purposes of this demo is bypass safeguards. And you can do that by typing Shift-Tab. And what that does is it basically runs SQL without checking with you every single time. And it makes it life a little bit easier and faster so that you're not constantly sort of proving simple actions. It's fine if you have a scoped role that doesn't have permissions to do a lot of things. At least that's with my particular use case. But you can sort of decide if that's what you want to do. The next thing I asked is, hey, help me create an agent, same schema, using the semantic view. And you can see how incredibly fast all of this is. It's just significantly faster than like trying to go into the UI and navigate a bunch of things. And while it's running, you can obviously go and do other things. In this case, creating the agent actually does 4 things. Initializes a workspace, and actually it'll build a JSON file which describes the agent. And so this JSON file might include the response instructions, the orchestration instructions, tools, all that stuff. And then it actually creates the agent via the REST API, and then it will verify that it's there. So while it's running, maybe I'll switch back to James really quick and ask, I don't know if there's any questions that have come in so far, if there's any things that we can talk about while it's running through this.
Yeah, so we had one great question here so far. Semantic YAML files seems like the old method with the semantic models that we built. Isn't the new method is to create semantic views in the database?
Yes, that's a really good question. The answer is yes. We do want to create semantic view objects in Snowflake. However, the YAML representation is not going away. So even the semantic view object will still be representable via a YAML file. The specific thing that's going to go away ultimately is having the YAML file live on a stage and directly talk to that from Cortex Analyst. That's a path that we're going to support less and less. And the reason is that YAML files direct without the semantic view object, you can't really query them with semantic SQL. You don't get the same types of validation that we can do with the semantic view object and so on. So you'll just get much better results with the object. But you can still create a YAML file to represent it.
Yeah, I have another question for you. Actually, it looks like your instructions are done. So
Nice.
let's go ahead.
Yeah, let's keep moving. So great. So it's actually created an agent, and so we have a test query that was run. It confirmed that the agent was created, and then it asked me, "Hey, do you want to do some next steps like optimize the agent, test the agent, add relationships, and so on?" So this is coming into the fun stuff, the stuff that actually takes a while in the UI or might take a while to discover. And so I think probably the most easiest, lowest hanging fruit here is like the semantic view is not really usable without relationships. So maybe we'll just ask it like, yeah, tell me what relationships I should add. And Cortex Code should be able to take a look at tables and sort of figure out, hey, here are some columns that maybe seem related and things like that. And so let's give it a minute. Or okay, wow, it's pretty quick. It seems like, yeah, it's actually found a few useful columns that we might want to join. Customers and ticket sales, obviously we want to join via customer ID. Customers and merch sales, definitely want to join via customer ID. And support tickets, also a very reasonable join. There's also some event ID joins relationships that we want to have. Events and ticket sales, events and merch sales, events and support tickets. So 6 really great relationships. Let's maybe just start with one of them. Add in, the following relationship. And, ask me if you have questions. I don't know if it will know the type of relationship offhand. Maybe it'll take a look at the actual data. But it should be able to read the YAML and sort of understand the structure and so on as it's trying to do.
Yeah, as it's doing it, a great question came in from I'm lazy and I know it.
Nice.
What's the difference between what we're utilizing in terms of the skill to what we see in the UI itself when we build out the semantic view?
Great question. So right now, what you have in production, the skill, it has most of what the UI has. And in coming few weeks, we're actually going to ship all of the features that exist in the UI in Cortex Code. And so more and more, we're going to suggest that Cortex Code is a great place to sort of edit and create semantic views and so on. As you can see, like here's one of the cases. Like I think relationship addition, the first time it tried to do it, it seems like it sort of hit a validation issue. And this is the type of thing that in the coming 1 or 2 weeks, we'll give it exactly the same code that the UI has, so that it doesn't even cycle. It sort of hits the right relationship the first time. In general, today, Cortex Code is pretty good at recovering from its mistakes. So even if it takes a minute, it will ultimately work. Cool. Any other questions, James, while we wait for this to go through?
I think in the beginning you mentioned you're using 36 columns for this. Um, when you wrote out, you and the team wrote out the best practices for semantic views, you mentioned it was mentioned that you want to keep it kind of scoped to like 50 to 100 of them. Uh, why is that? And when do you make that decision of like, oh, should I just include a couple more or split them off? And
Absolutely. Great question. So the recommendation on column numbers is ultimately to do with your ability to sort of maintain the initial semantic view and just understand when things are going wrong and fix them. What we noticed in practice is that when people create very, very large semantic views for the first time, it can be thousands of lines of YAML, and then it's pretty hard to actually fix issues if they come up. And so the recommendation is mainly for ease of use for the human. On our end, we do have various techniques to prune down and reduce large semantic views so that they fit into LLM context windows. And so now if you're using Claude or GPT models, we actually dynamically prune down semantic views. And so there's no actual limits on the columns and tables there. Maybe one caveat I'll say is if you're using it in the UI and you have maybe over a 2 megabyte file, the UI can actually just crash the browser. So that's the one sort of limit on the browser side that can happen. But besides that, yeah, we don't really have limits.
gotcha.
Cool. All right. So in the meantime, it looks like, hey, this relationship was added, and it didn't even have to ask me any questions. It said ticket sales to .customer ID to customers.customer ID, the relationship was added. It added a many-to-one relationship, which is the correct thing because a single customer can purchase multiple tickets. And so now we can ask all kinds of queries and ask for it to do different types of things. Let's try something else. So I'm going to ask, can you add in a filter for VIP customers that only looks at customers who have purchased over 150 in tickets, something like that. And let's see if it can handle something like that. So this is a different kind of ask. It's actually asking for us to add in a filter automatically. And today in the UI, you have to sort of go in, click add a filter, and then know exactly what expression you want to add. And it's a bit painful because you could have a syntax error in your filter expression, especially if it's complex. This is actually not a very complex filter, but once you get into very complex like case statements and very large filters, then it gets hard to maintain. And so asking Cortex Code to do that ensures that you can potentially the first time it will get a much better quality valid filter that you can then use. And so
something that's refined at the end.
Sorry, could you say that again?
Oh yeah, it sounds like it allows like refinement instead of
100%.
as a user you might as you're going through building out this case statement, like you said, you might just put everything in everything. But it sounds like Cortex Code might be able to take that extra loop around to kind of make sure it's covering the right stuff.
100%. And so you can see here exactly what it's done. It's actually named it for you, VIP customers. It's put in an expression, and this is the part that it's easy to sort of sometimes get the wrong expression and sort of maybe potentially make a syntax error here because this is SQL. You have to get that right. And then it's put it in a particular table, ticket sales, which sounds fine. And then it's put in some synonyms for this as well. Maybe one thing I might want to do is move this to the customers table. Or maybe I should, yeah, so let's ask it. So should this be in the tickets table? And this is a good use of Cocoa. It's just like asking questions and trying to understand whether this makes sense to do. And these are all capabilities that Cocoa now has because it understands the semantic view. It understands, what's a good practice and so on. So let's learn. Here's a fair question. That's a fair question. It depends on what you mean. The current placement, the filter applies per row, so it filters individual ticket purchases where price exceeds 150. Okay, and then on the customers table, you can't put it there directly. And so you'd need to have well, one thing that we are shipping very soon is Cocoa's ability to do derived metrics, so you can do cross-table metrics. So in the future, it will hopefully suggest, hey, you can do something across multiple tables. And potentially also entity level filters is coming soon. And then ultimately comes down to your intent. Yeah, this is great. I mean, this is a great answer. So ultimately, I can sort of guide Cocoa exactly what I want to do, and tell it, exactly what kind of filter I want. Cool. And then last thing, maybe I also want to show, and I don't know how we're doing on time here, James. If there's any other questions, we can also take those. But I also would love to show how you can test your agent. So one of the things you could do is say, and I have something pre-baked here. Let's ask it, how many, well, let's say, given the current definition, how many VIP tickets were purchased in total, across all music festival tickets. And this is something Cortex Code has access to do. It can sort of actually write a query to your agent and check that it's working correctly. And in this case, it'll hopefully return some number using the expression that we've put in.
Yeah, as Cortex Code's doing its thing, a good question came out. So it's for the relationships that we just went over, do we need to specify whether there should be like an inner join or a left join? Because today in the UI, we don't have such things, but have values like this as well. So is there a difference, and how do you handle that?
Yeah, absolutely. So I think you don't necessarily, well, you wouldn't necessarily want have to specify inner join or left join. Like in our case, the assumption was made by Cortex Code. And so if it's obvious, you would think that the LLM might just figure it out from the type of relationship you're trying to create. The other thing that we have in our relationship suggestions that very recently shipped is the ability to actually check the cardinality of the left and right column. And then you can make an inference on which what type of relationship you want. And that's maybe less for inner or left, but more for like many to one or one to one thing, that type of classification. And so that the suggestions are going to be coming to Cocoa in the coming release in a few weeks. And then the last thing is you mentioned today in the UI we don't have such a thing, but we have values like as of. So how's it different? Yeah. So again, this initial version of Cocoa, you can sort of create basic relationships. So like the basic one-to-one, many-to-one, and so on. You wouldn't necessarily need to specify inner or left. The semantic view itself handles that. You just need to say which side is unique. And then in terms of as of joins, that will come in a future release in Cocoa. But the intention is for the UI and Cortex Code to be one-to-one in parity. We're just getting there. Cool. Okay, so I think this is actually run. And so it's actually given me a result. Some number of VIP tickets was purchased in total. And, this is so if you have like an existing BI tool or a dashboard or something, this is a great way to sort of use that to then you can sort of validate that this answer is correct, that it looks right. The warehouse fix worked. And then the agent used ticket type equals VIP. Awesome. Okay. And not the VIP customers filter. Okay. And so maybe this is something that we can add to the agent orchestration instructions. So add in agent orchestration instructions to make sure that it always uses VIP customers instead. And actually, maybe this shouldn't live in agent orchestration instructions. It would normally live in semantic view custom instructions, but I'm just going to send this anyway just to demo exactly how this might work if you specifically asked for this, because Cocoa has the ability to edit the agent and make changes. And so in this case, it should understand how to add orchestration instructions. Anything else that's come in, James, in the meantime?
Yeah, there's a long one. So I'm
Okay.
gonna have Rita put it up. It's what are the best practices? So it's really about complexity. Like where can you trim down complexity so that way query times don't take as long? Essentially, is the question itself. But because of so many details, I'll let you kind of read it through and
Yeah.
break it
Let me
apart.
take a quick look. So, what are the best practices for building semantic views when the model requires multiple relationships or joins? We're noticing as number of joins increases, query compilation and execution time can increase by a few seconds. Yes, I think that's expected. So then in this case, is it better to keep the logic in the semantic view or to pre-compute or denormalize the logic into a separate table? Yeah, so both of those have been done before. What are the trade-offs? I mean, it sounds like you're very latency sensitive from this question. So if you're extremely latency sensitive, I would say that typically the pre-computing option where you like pre-aggregate numbers has shown results for many customers. And so that's one option, and then point the agent at that. Um, but usually, if you're not that latency sensitive, this latency comes from actual SQL execution latency. So there's not a whole lot that we like. Even a BI tool would have the exact same latency. And so there's not a whole lot that we can suggest besides pre-computing. One thing that you could take a look at is the SQL being produced actually efficient? So for instance, if it's not passing down filters and things like that, then you might sort of land up with a very inefficient query coming from Cortex Analyst or Cortex Agents, and then one of the things you could potentially explore is instructing it to sort of apply the filter at a certain point in time and things like that. And so sometimes, in some cases, those types of instructions can help. But that would be my general guidance. I mean, both of those have been done before.
And Abhinav, if it's a query that is familiar and known, verified queries could support this a quicker turnaround time too,
100%.
right?
100%. So, yeah, so maybe I should have also mentioned that. So, verified queries are a great way. If you understand the shape of the question, you can sort of have a VQ, a verified query, that then every time it matches that, it sort of uses that SQL as inspiration, and then you can sort of shape the answer as well. Yeah, cool. And so it seems like the agent has, Cortex Code has done its thing. It's actually, well, let's scroll back and see what it actually did. Um, okay, it actually deployed the updated agent, retested, and then it said, let me check the generated SQL to confirm. Great, so it actually understood my intent. Looks like the orchestration instructions are working. Awesome, so before it used this filter, after it used that filter, which is what I wanted, and look, it returned a different answer. Hopefully this aligns with whatever BI dashboard I'm using. And cool. And then the agent's thinking also, so it checked the intermediate steps of the agent to make sure that the SQL was generated the way we wanted it to be. So this looks really good. Cool. Is there, how are we doing on the question backlog, James? Should we sort of demo more things or go over questions, or do you want to sort of, yeah?
Yeah, I say we go over some questions and maybe it'll come into you showing some stuff off.
Okay.
The question I want to go over is there any time series examples or use cases that can be shown?
Yeah, great question. So, in general, time series sort of it's supported out of the box, and so lots of customers have things like this. In this particular example, let me check if we actually have a time dimension here. I'm not sure offhand, and so you'll have to maybe give me a minute. Is it possible maybe to come back to this while I take a quick look and see if we actually have a time series one in this?
Yeah. That sounds
Maybe
good. I'm gonna
if
go
we
to
can
like
go to
a
the next one, yeah.
yeah. It's a question that was actually asked a little while back. It's how can you create semantic views? So how can semantic views be created where you already have all the required fields in a single table by consolidating with utilizing dbt?
Yeah, so that's a great question. There's a couple of options, and people do different things here. And at Snowflake, we're sort of still working through um, maybe like a very highly blessed recommended option. So in the meantime, I'll at least present to you the different options you have. So one of them is you can have your actual semantic view in dbt and materialize it in Snowflake. So then you maintain your source of truth in dbt and not in Snowflake, and then you would make updates and changes in dbt. The upside of this is that you get whatever tables that you've defined in dbt, all the things that you've defined in dbt, you get to sort of leverage that. The not so upside, like downside here, is like you can't use our Snowflake semantic view editor, and even Cortex Code might struggle because the shape of the semantic view is not the Snowflake type of semantic view. It's in dbt. And so it will not be able to make edits as easily to the semantic view. But you'd be on the dbt stack at that point, and so maybe there's other things that they have to help you edit those semantic views. The other option is to actually create it in Snowflake and maintain it in Snowflake. If you have existing things in dbt, one of the things that we're shipping in POC is a ability to ingest your manifest.json from dbt and create your semantic view from that. Our first version will be a one-time ingest, and we're actually going to have this in preview starting in the next month. But at least Cortex Code will have the ability to do that, so you should be able to sort of create semantic views relatively quickly and easily from your dbt manifest.json. It'll be a deterministic thing, not that the LLM is just pointed at a giant JSON file. We actually parse it. But basically what you'll be able to do is create a semantic view from that. And then, so those are generally sort of the two options. And then in the second one, you're essentially maintaining it in Snowflake, and then you get to use the UI and so on. And then maybe a third option that some folks have done is sort of create their own custom pipeline where they sort of use a bunch of templating to sort of produce a semantic view YAML file from their dbt setup. And I know a couple of customers have done this. And then you actually get a YAML file at the end, and then if you wanted, you could go into the UI and edit that as well. But that's a little bit more custom work. But maybe those are the sort of types of options that I've generally seen. Yeah,
that makes sense. While we're still in dbt land, we have another question. So this customer or this user has they say we use dbt to create the semantic views and agents themselves. Is it still required to deploy production agents into Snowflake Intelligence database? And also, what are the best practices for authorization for an agent?
Yeah, I believe for now the answer is yes. And when you say best practices on the authorization, I assume we're talking about who gets access to them. And so right now, Snowflake agents, they are first-class Snowflake objects, and so you can have regular Snowflake RBAC and all of that apply. And so maybe the general sort of thing, I've seen maybe two patterns over the last several months. And so one pattern is that you have a service account, and then so the service account then has access to sort of execute queries, has access to the agent, and then gives results to end users. And then the other general pattern I've seen is like every user gets their own Snowflake account, and then the results are scoped by whatever the user has permission for. Ultimately, it's a little bit of a individual decision on which of these you want to go with, and depends on the trade-offs of each option for you. But hopefully that gives some very high-level guidance at least.
Yeah, thank you for that.
And maybe actually, if it's okay, I know there was that question on the time series, just to follow back. I don't want to drop it, but I think this particular demo didn't have a very good time series example. And so maybe what I'd say is, in general, you can treat time dimensions as similar to maybe other types of dimensions, in the sense that you can sort of do you can create expressions and transform time dimensions by changing time zones or whatever it is that you want to do. We've seen all kinds of examples like that from other customers in the past. And then I think one thing just to be careful of is making sure that the agent and analyst is aware of the general time dates. So one trap I've seen is like in sample values or in descriptions, you put in very specific dates, and then that guides the analyst or agent to produce answers that are in that year. So let's say, for example, you have an example or a sample value or a description that refers to the year 2005 or 2025, sorry. And then now it's 2026. And then you ask a question, and then the answer sort of defaults back to 2025. And so being careful about that and not avoiding very specific dates, but rather like the general guidance and descriptions is another best practice, I'd say, that I've seen can be helpful. But yeah, hopefully that helps.
Yeah. Another great question that we have here, I think this is something that a lot of us are curious about, is if you have more than one semantic view, we'll be able to cross-join them across those views, and how does it handle those questions if you're using like the Cortex API, right, Agent API, or I guess even in Snowflake Intelligence?
So basically, if you're across semantic views, currently we're not able to do joins between multiple semantic views. So instead, what you could do is have multiple tables in a single semantic view, and then perform the join between those tables. And there's no limits on the size there. So that's what we're able to do.
Fantastic. All right. I think we are at time. Thank you so much for everyone for being here. Abhinav, thank you so much. It was great to have you here and answer all these questions. And builders, we'll see you next time.